particular challenge that we had if you looked at the labs. So I encourage you to go through the labs, go through the materials, go through the lesson materials, and then catch up. So note, we are not using these code blocks. Question, how do you know where to put your RGB? And the question is anywhere on the circuit as long as you on the PCB or on the breadboard, as long as you don't short circuit it. So I just pick a random place on this column section. Note, you don't put it here because you create a short circuit. If you're unsure, just hover your cursor over it. You see the full connection. Doing the baby step or the step-by-step approach. So according to the lab, we've got this code that we need to make work. So if I try to simulate the code, unless I have the actual thing pointed out on here for me. So if I try to simulate the code, maybe no errors. Let's see the output. Nothing much happening. But first of all, I get the impression that there is something missing, not just because I'm being told to fix the errors, but obviously nothing happening on the output. Right, so first thing I know is missing is that basically I am doing a digital write to these pins. And I double check to see whether these pins, okay, I zoomed in too much. It keeps repeating itself for here. Right, so basically I double check, am I using the right pins? So I have A1, A0, A2. Yes, I'm using the right pins on there. Okay, that's good. So there's an integer value. Okay. Now, I am doing a digital write, but I've not told the compiler what pin mode I'm using. Now, I don't really know at this point. Yeah, it's okay. We can adjust it. Good point pointing out. Just looking at the right pins connected anyway. So, and then you've got green to, actually the blue is A0, and then the green is, the blue is A2. Blue is A1 and the green is A2. Right, thanks for pointing that out, Mohammed. Right, so basically I'm thinking, okay, so if by default these pins are considered as an output, great, it will work for me, but in the code it wouldn't help me much. So let me fix that part by saying pin mode, not digital, pin mode, and I have the LED red that's going as an output. If you've forgotten this, you just make a reference to the lab reference that we are using, and it needs to end with a semicolon. So I need to do it for each of the zoom in a bit more. You don't need to copy my code. Basically, you've done it on your end, right? And we are going through how I fixed it, but you basically don't need to copy my code exactly as it is. Remember, turn it in, double checks everything. So if you give me back my code, basically you're just going to have a high similarity. This is just an approach as to how I solve it. And the key thing is, please remember, there's no one way of solving things, but they are the optimized way of doing things. And the key thing is, you need to be able to figure this out yourself. You need to be able to work it out. I hope that helps. So in this case, I'm going to enable the serial begin. We've not talked about the serial begin yet, but it helps you print to the serial monitor. If it was a real Arduino, you can see the communication between the board. And I noticed that the void loop function, there is nothing in there. So just as we saw in this code, if there is nothing here, it means my processor or the 80 mega 32.8p will get stuck in this loop doing nothing, right? So I need to find something for it to do within the loop, but at the same time, I see this cycle function. And the cycle function actually is calling this particular code, which cycles through red, green, and then blue. So if I start my code, hopefully the zoom in wouldn't doing things. But if I start my code, if all the connections are correct, I expect it to cycle through this at least once. I'll put break in there because it's in debugger mode. Let me turn off debugging so I can stop and start. Yeah, so I noticed that it cycles through the colors at least once. This, from coding perspective or from usability perspective, is to show me that the Arduino is plugged in, or the 80 mega 32.8p processor is actually running something. It's running a code. So to make it cycle through it continuously, I just need to call this cycle function from the loop. Remember? Right. So that's all I have to do. I don't need a for loop. I don't need anything. I just put my function in there because the loop function will execute itself continuously. So that's the first bit. Then it gets in here and automatically it's going to go through the cycle thing forever for me. So first, that's complete, and it's not much to do. It's just simply calling this function from the loop function. All good? So by raise of hands. Waiting for more hands. I've got only a few hands up. Please share by raise of hands. Good. Good. Now you can lower your hand. So you notice the emphasis is transferable skills. The emphasis is being able to use the syntax you've read to identify where in the code that you need to make changes. And understanding of this is really important because we are still at a very high level programming language stage. So as we dig in a bit deeper, you need to understand how the registry is laid out and how communication happens at the lower level. Okay, so the second task was to make use of this rainbow function. And at the moment, the rainbow function does nothing. So if let's say we comment out the cycle through and we call the rainbow, nothing happens. After the first stage, nothing is just going to happen. And so this is the first stage, is just this cycle function. Now it's finished the setup and nothing happens. So that's the second challenge, is to use the rainbow function. If you want a very lazy or very quick approach, I'm going to call this other cycle, so at least we see how the cycles work. So let me call the alternative cycle and get back to work, but let me call it delay. 1 second. Right, okay, so missing my column. Okay, good. So basically, I've just called the other cycle. It's going to show some colors anyway. But if you want a very lazy approach, or a very like gives you less flexibility, you could simply copy the cycle and paste it in the rainbow function for the rainbow function to call it. But there is not much to learn by doing that. You don't really benefit much. But the key thing is we want to make use of these colors, because so far in here we are not making use of the colors. So let's call the color functions. You can call red LED from here without any loop. Without any loop. Just all of them. Red, green, may not necessarily be the order of the rainbow colors. Let's call it in white now. Purple, yellow, orange, cyan. And now what we want to do, because if we execute it now, we are most likely to get the colors mixing because each color stay on. So we're not going to get proper red, green, blue. I've got a hand up. If you want to ask a question, please type it in the chat window. If I'm not answering your questions, let me know. So now we've got the colors missing and not really telling us, helping us much in a way that we want. So what we would want to do at this stage is to introduce, switch each light off each time we switch it on. So red on, red off, green on, green off, blue on, blue off, white on, white off. So each color we switch on, we switch off, switch off, and to complete the statement, I add my semicolons at the end. Note all this can go on one line, but we want to put a delay so we can see the color change. So for each time it comes on, I'm going to put a delay before I switch it off and switch the other on. But you can actually make it more visible by staying off 1 second before. Remember, I'm just adding my own flair of creativity as I go on. You can mix the color in any way that you want to make it visible, as long as it's visible or you follow the similar principles. And the orange, and cyan, pink, and then stay off before it goes to the next one. How to make the color cycle? I've got a question from Varun. Varun, basically you've got a cycle LEDs function on here for you. And the whole point I've been creating from the beginning to this stage is that code in your setup works only once. Code in your loop function goes in a forever loop. You can put a while just to make it run faster, but you don't really need it. And to make it cycle, all you have to do is just call the function once here, because you can tell from your blinking LED from week one, what we've been doing from week one to this stage is that the loop function, whatever you put there, will keep repeating itself anyway. So let's give this one a go. Hopefully there are no errors. So we've got the first red and blue, and then it goes into the rainbow loop, red, green, not necessarily blue, but it goes to the white. From white, we are now on yellow, then we are on the orange. Mix the colors. I should make it more readable. So at least I'm going to on this so it becomes readable, readable, readable. Let's put a delay after the off on there so at least you can see the color change. Perfect. So I hope this helps clear some doubts. And the reason why I've gone through the challenge with the whole class is just simply because I want to bring you up to speed. I want you to understand the scope. I want you to be able to make use of the reference notes and be able to write your own code. I want you to bring in your programming skills, even the new ones that you've adapted and everything. And in here, please note one is dimmer than the other because obviously we're connecting common cathode to ground when it's not. Right, but at least we get a concept. You can add your own creativity. You can add this switch. So basically, if you press it, nothing will happen, or you press it to initiate the whole circuit or to initiate the LED blinking, or you can even use the state of the switch to change from, let's say, the rainbow colors to, let's say, the cycle. You can use the switch to control the execution. There's quite a lot that you can do. I know at the moment we are blinking LEDs, but remember, you combine your RGB code with the motion sensing and the other labs that you are doing, and you want towards something beautiful. All good? So I'm gonna do something. So I'll just want out a message to the serial screen. And no errors, it should work. So we've got code running, and then it goes into the loop now. So we've got rainbow running, so we've got the rainbow colors changing, and we put too many delays, so it's going to take a while to finish. And just to show you the loop running a few times or forever, so you don't really need a for loop in there. The clue to that answer actually lies in the connection of the resistors to the pins. So you can see this one, you've got the value actually, you've got a common cathode being connected to ground. So if you look actually to common cathode, common and RGBs, you will be able to understand it straight away. So the secret lies in here, and I thought it was visible before you, so you can see it. So far we've got the loop running 3 times. So each time this loop runs, it's going to print to the rainbow, to the serial monitor for us. One useful feature of this particular tool, which you actually won't find in the actual Arduino IDE, is that you can click the debugger and turn on the debugging mode, and you can double click anywhere in your code. So when it gets to that particular point, execution will halt or execution will stop. Let's turn on. Okay, so get it to run. Pause a bit before that. Yep. So I got a function running and I clicked on that. So if on here we notice that the execution has stopped on this particular stage. Actually, let's go a step further before we switch it off, and we can have a better view of things. Did I go through the whole thing? Yep. So basically, you can use this to step over code or step through the code to debug your code and make things even more exciting step by step. All good?